Hello everyone, you are welcome to this class. In this class, we want to look at another concept, and that is circle. Let's look at properties of circles. So under this, we'll be looking at these objectives. So number one is that we're going to look at the properties of a circle. Then after that, we look at the formula for calculating length of an arc and its examples. Then look at perimeter of a circle and area of a circle. Then the next class will look at other aspects of properties of a circle that has to do with formula. Now, for the purpose of this class, so when we talk about circle, so it's not something, circle is a plane shape. It's a flat shape that is like this. This is a circle. It's not new to us. This is a circle. Alright? So it has a center. This is the center of the circle here. Alright. Now, the line that moves around to form this circle as its name. You know, when we were treating perimeter of plane shape, we said perimeter is the side. It is the distance that rounds a shape. So we have a square like this. So the perimeter of this square is the distance that surrounds this shape, this square. So this addition of everything here gives us square. But for circle, perimeter of this circle, you can see the distance that moves around like this is the perimeter of the circle. Is the perimeter of the circle. There is a difference between circle and a sphere. Ball is not a circle. Ball is a sphere. But flat shape, flat objects is what we refer to as what? Circle. I hope I'm making sense. So this line here is called circumference. Circumference. So that is the distance that rounds the circle. And since the distance that rounds the circle is also referred to as the perimeter of what? Of the circle. So take note of this. Because when I can ask you to find perimeter of a circle, they are as well asking you to find circumference of a circle. Or they ask you to find circumference of a circle, the same thing as what? Perimeter of a circle. We're still going to look at the formula, so which we have learned before already, but just show you the formula so that you know how to apply them. Then that is number one. Number two is this. Any point, any line drawn, please take notes, any line drawn from the center of the circle to any part of the circumference is the radius. So as you draw a line here, from here to this place, this line is called radius. I hope this is very clear. Right. Now, if you now draw a line from one part of the circumference to another part of the circumference, and the line passes through the center of the circle, so that line is called diameter. You can see this line passes through the center of the circle. So this line here is what we refer to as what? Diameter. I hope I'm making sense. One thing you are going to notice here is that the diameter, you know, if you draw this line, if you join it from here to here, this is the radius, this is one radius, and this is another what? Radius. Meaning that two radii give one diameter. Two radii, this one radius, this one, the plural of radius is what? Radii. So radii like this. Are you with me? So two radii here give us one diameter. That means we can say that 2 radii is equal to what? 1 diameter. So all these are very, very important to understand them, because by the time we start solving questions now, so some things will be coming up, and it will help you a lot if you understand all these little concepts. All that's very clear. So I'm going to draw another circle now. I'll draw another circle. So this is another circle, right? So we've looked at circumference. So we look at radius, we look at diameter. The other one is that looks like diameter, but it's not the diameter. You know, I said a line drawn from one part of the circumference to other part of the circumference, passing through the center, is called diameter. Then we also have when a line is drawn from one part of the circumference to another part of the circumference, and the line does not pass through what? the center of the circle. This is not a diameter because this line is not passing through the center of the circle. So this line here is what we refer to as chord. Chord. This is a what? A chord. I hope I'm making sense. So from here now, we can have another. Let's look at this. So let me draw a radius. This one radius. I have another radius here. You can see. So this is radius. They are the same. They are always the same. This is a radius. This is a radius. Now, this line from here, this line here is the circumference, right? If I now cut this out from here to this place, from this place to this place, so this line here is called an arc, A-R-C. This line from here, it is a part, an arc is part of a circumference. An arc is a part of a circumference. You can see that I'm cutting out this from this place to this place. From where? From the circumference, from the whole circumference. So part of a circumference is called an arc. There's something we're still going to look at. That's when we're looking at length of an arc. How do we calculate that? It's very simple. You see how we're going to derive the formula in this video. And that is that of that one. Then, if you now look at the region covered by an arc and the two radii here, this region here, that looks like pi. You understand? That looks like pi, as in, what's it called? Pizza, rather. When you have pizza, you cut it to different sectors. This, you have a pizza like this that looks like this. You now cut it into different sectors so that you can pick your own. You understand? So this region here that is being cut and given to you is what we call sector. This is sector. So sector. That is, a sector is a region bounded by an arc and two radii. It's a region bounded by what? By an arc and what? Two radii. Now there's something I want to show you here. So let me draw another circle here again so that you can get it correctly. So we have this. Alright? Alright? So we have the center. Here is the center. So we have this line and this here. This is radius. So this is an arc here, right? Now this region here, we have two sectors here. The first one is this one. This is a sector. And it is bounded by this angle here. That is this sector subtend. This is how you're going to know the angle of that sector. I can bring this out now. If I should bring it out, this is what it's going to give me. I'm going to have something like this. This is the sector. This is the angle. So the angle must be inside the sector. So the sector here is what we call, this one is small. Why this one is, this is also a sector. You understand? Because we are talking about from here to this place too is an arc. This is also an arc because it is a part of the circumference. So this is another arc, but bigger than this small arc. So this is a sector because it is bounded, all this place here, this one is also a sector because it is bounded by two radii and an arc. So this one will now be what? Major sector. Why this one will be what? Minor sector. I hope I'm making sense. So this is very important. By the time we start calculation, you see the importance of this. Alright? So that is that on sector. Then there is another one that we need to look at. The base one, which is we're looking at this. I said this line here is not a diameter. Alright? This is not a diameter. This is called what? Chord, as you can see. Now, the region bounded by an arc. The region bounded by an arc. This is an arc from here to here. This is another arc and a chord. This is a chord. This region, not line, region. This one that I said region. So it's called segment. Segment. So this is a segment because this is bounded by this chord and this arc. This one also, this is a chord and this arc. So this will then become major what? Major segment. So this is what? Minor segment. So that is that on the properties of circle that will help us to do some other calculations. Now, we're not going to go into length of an arc. How do we calculate length of an arc? When we talk about length of an arc, that is, what is the formula for calculating this length? This length. But before we do that, you must know something. So let me erase this and then come back. All right, we want to calculate, the next one is length of an arc. Length of an arc. That's what we want to calculate. But before we calculate that, I said an arc is part of a circumference. So what is the formula for calculating circumference? So formula for calculating circumference, circumference of a circle. We've learned that in your previous classes. Circumference of a circle, which is also known as what? Circumference of a circle is also known as perimeter of a circle. I've said that. Of a what? Of a circle. And that is calculated by what? 2 pi r or pi d. Exactly. So 2 pi r or pi d. You are going to use this formula if radius is given. And you can as well use it if diameter is also given, but the variable you use was pi d. Why is it pi d? I said that 2 radii equals to 1 diameter. So here too you have 2 radii times pi. So instead of using 2 pi, I'll just use this one to the place of d. So that's why we have it to be what? Pi d. I hope this is very clear. But that is not what we're doing. We want to find length of an arc. So because arc is part of a circumference, so we're not going to look at this arc subtend an angle, which is this place. If you are looking at this arc, the bigger arc, it will subtend at this angle because this angle will be facing it. This angle is the one that's facing this one. So this angle is the angle this bigger arc subtend at the center. Why this theta here? So we can call this one beta. So why this theta here is the angle with this small arc subtend at the center of the circle. So in this case, what you calculate is this arc is a fraction of a circumference. So we're going to say, because it's a fraction of it, it's going to be length of arc is equal to theta out of the whole angle that we have here, which is going to be 360 degrees, times length of the circle, the total of it. You want to take the fraction, which is not subtend at the center. You want to take the fraction out. So that will be times 2 pi r. So this, once you can record that an arc is part of a circumference, you are able to remember, recall the formula for calculating circumference of a circle. You just know that it is theta over 360 times 2 pi r. That will give you what? Length of an arc. All this is very clear. Right? So let's look at an example and see how we're going to apply this into a question. So this is the first example here. So an arc of a circle whose radius is 10 centimeters subtends an angle of 60 degrees at the center. Find the length of the arc. So this is the question. So that means if you draw, it's not necessary for you to draw the circle, right? But let me just draw it for explanation purpose. We have a circle. The arc is going to form, this is the arc here. This is the arc here, right? So it subtends an angle of 60 degrees at the center, and the radius is what? 10 centimeters. 10 centimeters. So find the length of the arc. So we'll come out to the formula. So the formula is what? Length of arc, which is what? Theta divided by 360 degrees times 2 pi r. So what is the theta in this case? That's the angle the arc subtend at the center, which is 60 degrees, divided by 360 what degrees, times 2, the pi. Sometimes the examiner will give you the value of the pi, 22/7 or 3.142 or 3.14. Anyone given, make use of that. 22 divided by 7. What is the radius? The radius is 10. Then we then calculate it. So 0 cancels 0. 6 here 1, 6 here 1, 6. 2 here, that is 3. 2 cancel 2. So that is that. So that means we have 22 times 10 root of 220 divided by what? 3. So 220 divided by 3. So this gives us 73.3 centimeters. So that is the answer. You can see it's very simple and straightforward. So that is that on length of an arc. Now let's now go into perimeter of a sector. Perimeter of a sector. So we have known what a sector is. This is a sector. We have a sector here. We have sector. Alright. This is a sector. So we want to get the perimeter. So perimeter of a sector will be this radius. Perimeter of any shape is the addition of all the sides. So which means we are going to add this plus this and plus this. That's the perimeter of a sector. So in that case, we're going to have this. So perimeter of a sector. So perimeter of a sector is equal to R plus R, that's what 2R plus length of arc. So because we have this is length of arc plus this gives us the perimeter of this sector. Now we have known the perimeter length of arc to be what? Theta over 360. That's 2R plus theta over 360, length of arc, theta over 360 times what? 2 pi r plus 2R. Am I with you? So we can factor out this one and move on. So let's leave it like this. So let's look at the example on this. That would be example 2. Alright, so find the perimeter of the sector below. This is a sector here. You have to find the perimeter. That means this plus this plus this. So this is radius. It's not given. This radius. That means this one is also what? 12 centimeters. And this is a length of arc. So this length of arc, that's what we're going to find. So the angle subtend at the center of this sector is what? Look at that square shape. Square shape is what? 90 degrees. So this is 90 degrees. That means perimeter solutional. Perimeter of sector will then be equal to theta divided by 360 times 2 pi what? 2 pi r plus 2r. So what is the theta here? That is 90 divided by 360 degrees times 2 times 22/7 times radius. That is what? 12 plus, this is plus, not times, 2r. That is 2 multiplied by what? 12. So we can cut this, 9 here 1, 9 here 4. Alright? 2 here 2, 2 here 1, 2 here 1, 2 here 11. So here we have 11 times what? 12. And it's not necessary for you to cut this. You can use your calculator to calculate the space. But make sure that you are not adding this one straight. So divide by 7 plus 2 times 4, that's going to be 24. Alright? So we use this one. Calculate this 11 times 12. 11 times 12, that's 132. 132 divided by 7 and gives us, this gives 18.86 plus 24. Plus 24, that gives 42.86 centimeters. So I'm leaving it in 2 decimal places. You understand? It depends on the examiner. It has to be the whole number. That would be 43. So 1 decimal place, that's going to be what? 42.9. I hope this is very clear. So that is that on perimeter of a sector. Let's now go into the last one, which is area of a sector. Now, this is a sector here. Alright? And you can see that it's a portion of the whole circle. What we did when we were calculating length of an arc is the same thing that will happen here. So area of the sector here will also be, because now it now depends on which sector. Is it major sector or the minor sector? So if it is major sector, you're going to make use of this angle. But if it is minor sector, you're going to make use of this angle inside. Just take note of that. You're still going to come across that in exam. So in this case, we have theta, that is area of the sector. Area of a sector will be what? The theta divided by what? 360 degree times area of a circle. Area of that will be what? Pi r squared. Area of that by r what? Squared. So that is the formula for calculating area of a sector. Now let's look at the example. Example. So we have this, find the area of a sector below. So we have this. This is 14 centimeters. This is 60 degrees. So we want to find the area of this sector. So what we're going to do is the formula, the answer. The formula is area of the sector, which is equal to theta divided by 360 times pi r squared. So that will be 60 degrees divided by 360 degrees times 22 over 7 times r is what? 14 times what? 14. 0 cancels 0, 6 here 1, 6 here 6. Right? 7 here 1, 7 here 2. Right? 2 can go here 3, 2 can go here 11. So we have 11 times 2 times 14 divided by 3. So this will give us 22 times 14 times 14. So divided by 3. So that gives us 102.7 centimeters squared. And sometimes you might be given the area of the sector and be asked to find radius of the circle. So let's look at that example and see how we can solve that. So the question is the area, that this is going to be example 4. So the area of a sector is 204 centimeters squared. All right, and subtend at an angle of 35 degrees at the center. Find the radius of the circle. So the same thing. So it could be the angle that the sector subtend at the center that we asked to find. So you're still going to follow the same process. So also with that length of arc we just finished. Alright? So this is going to be in solving this, area of sector, which is theta divided by 360 degree times pi r squared. Alright, so the area of sector is given to be 204. We have 204 here. Theta is given to be what? 35 degrees. All over what? 360 degrees times 22 over 7 times what? R squared. So this is what we're going to do. You can decide to cut. 5 can go here, 7. 5 can go here, that's 5, 7, remainder 1, that is 72. 7 here, 1, 7 here, 2. Exactly. 2 can go here, that is 3, 36. 2 here was 11. So we have 204 equals to 11 r squared all over what? 36. Then you cross multiply here, that will be 11 r squared equals to what? 204 times what? 36. 204 times 36. So that gives 7,344 to 11 r squared. Divide both sides by 11. So this cancels this. So divided by 11. So that gives r squared will then be equals to 667.64. So that is r equals to square root of 667.64. So we find square root answer. This so this will then give us r will be equals to what? 25.8 centimeters. Alright? Alright, so that's 25.8 centimeters. I hope this is very clear. So don't forget, it's not going to cut. You cannot cut 5 here is 7, 5 in 30, 5 is 7, we mean that 1, that is 2. Then 2 can go here, that is 36. 2 can go here, 11. This 7 will cancel this 7. So you have 11 r squared left. Then divided by 36. That's how we have this. Then when you cross multiply 5 times 36, give us this. Then divide both sides by 11. You have it. Then you find the square root, and that is that. So that is that on this video. So in the next video, we're going to look at segments, length of chord. We also find perimeter of segment. We are find area of segment and so on and so forth. So we're going to meet in the next video. Bye for now.